You're having a great day. Today's learning video is all about our sun, the star that's closest to planet Earth. Okay, a few little facts. It's of course the closest star, not that far away. It's basically made of hydrogen and helium gas. Those are the two most prevalent things in our sun. Provides nearly all the energy. It's huge. Over 1.3 million Earths could fit inside it. And how does the sun make the energy? It comes from nuclear fusion, which we're going to learn about. Two atoms combine to form a new atom and produce energy. So a little bit more in depth here. We have two hydrogens combining together, getting squished together by the gravitational attraction. Boom! They form a helium atom, release a neutron, and produce energy. And of course, Einstein's famous formula, energy equals mass times the speed of light squared. The sun is the most massive item in our solar system. Therefore, the energy being produced is immense because the speed of light is 186,000 miles per second. Now let's check out the layers of the sun. We'll go from inside to outside. The core, definitely feel free to pause the video and take notes as you go. The core has the most pressure. Why? Because gravitational pull of everything is pulling towards the center, same as the Earth. Fusion is occurring here. It's hot, 15 million degrees hot, and it's basically hydrogen and helium moving outwards. The radiation zone cools down because fusion does not occur there. The atoms are still tightly packed. They're not tightly packed like in the core where the nucleus is touch, combine, and fuse, but it's taking a long time for energy to move through here because it's so packed. Okay? Going to the convection zone, still warm. Hot atoms are moving outwards while the cooler atoms begin to move inwards towards the radiation and core. Okay? The photosphere, this is the layer that we see. It's really the layer of the sun's atmosphere. It's only about 6,000 degrees hot. Okay? And there are sunspots on it, and we'll get into sunspots a little bit more later in the slide. The chromosphere is the second layer of the sun's atmosphere. We only see it during an eclipse. It's quite thin, okay, and it varies. You know, as you get away from it, the energy spreads out and actually tends to warm up a little. And then there's the corona, the outer edge of the sun. It changes shape and size, can only be seen during an eclipse. It's up to 1,000,000 degrees C because it's kind of concentrated in places, etc. And it's what's going to create the solar wind or solar energy. Here's a picture of the corona during a solar eclipse. So, solar wind, the last layer, I have it in purple and red arrows. It's the electromagnetic energy moving away from the sun, 2,800 degrees. It's really not, quote, wind like we have on Earth. It's just the electromagnetic energy moving through or away from the sun that was created during fusion. Other features on the sun, sunspots, these things that look like freckles. They're sunspots. They're cooler, darker areas of the sun. They create the solar wind. They have to do with magnetics. And every 11 years, they reach a maximum. The more sunspots there are, the more likely we are to see northern and southern lights. Prominences, loops or arches caused by the sun's magnetic field, and they are charged particles and atoms in there. Solar flares, intense spurts of electromagnetic radiation or storms moving away from the sun. Okay, they're charged particles once again. Okay, and of course the solar wind, the corona sends the streams of high energy particles from the sun, not visible to the naked eye, etc. And that's going to conclude, there's a couple of videos that I have that we can watch, but that's going to conclude everything about our friend, the sun. Hope you have a great day.